And welcome to this e-learning training module on implementing routing facilities for branch offices and mobile workers. We are going to describe some basic design considerations and trends in deploying routing facilities to the branch in multiple scenarios. We want you to gather some tools from this session that you can apply to your everyday job. So we'll make the module task-oriented and demonstrative, outlining an implementation plan and related considerations, and demonstrating the main tasks in carrying out the plan. There's no denying that branch office architectures face many challenges. Increasing bandwidth and network requirements are driven by a unified service network, transporting video, voice, and data, and supporting mission-critical functions and applications. Meanwhile, another developing trend is to consolidate data centers rather than operating local application servers. A primary goal with this consolidation is to gain centralized security and management control, in part to comply with corporate governance mandates driven in part by government and industry regulations. The dispersion of people, coupled with the consolidation of IT resources, has resulted in much larger WAN loads as distant users all contend for consolidated resources across the wide area network. This situation has left older branch offices plagued by poor application response times over the WAN link. Generally, as branch office sites develop, often without much strategic thought given to future requirements, equipment and services are added to solve specific problems. The result then is a patchwork of network devices, in which branch offices often have very different equipment and architectures. As a result, branch offices are often extremely costly to manage and troubleshoot. In addition, rolling out new services across inconsistent branch office infrastructures is extremely difficult. Branch offices that are built in isolation tend to run aging and separate voice and data networks, which do not benefit from the use of collaborative communications applications hosted in the IP call servers. Different circuit-switched private branch exchanges, PBXs, from different vendors might exist at various branch office sites, each with its own feature set, proprietary technology, and special operational requirements. Meeting these challenges demands a formal branch office strategy and deployment plan. In addressing these challenges and defining an effective branch architecture, network designers must consider a multidimensional approach to branch design. If we look at these scoping and profiling questions, they all align to a structured approach that should consider specific areas. Remember, our objective here is to implement routing facilities for the branch. So let's consider how these areas affect the routing design. For instance, your choice of access and connectivity technologies will not only determine bandwidth and service availability. Technologies such as DSL and cable provide dynamic IP addressing and default routing at the moment of connection. Traditional VPN technologies like IPsec do not support dynamic routing protocols. Complementary technologies such as GRE tunneling must be considered. Resiliency considerations will typically result in alternate paths to the central location and other branches. This will have an impact in your choice of routing tools in terms of routing convergence, backup routes, load sharing, etc. Your choice of routing protocols is important if you want to take advantage of specific features such as unequal cost load balancing or stub routing in EIGRP. The traffic and service mix will also have an impact in routing facilities. In deploying branch services, the deployment plan should consider the existence of features such as NAT, quality of service, access control lists, and WAN optimization. Other considerations include security and mobility requirements. The branch is not only connecting to a central office for service delivery, but also serving as a connectivity hub for mobile users in their quest for those services. Each user now becomes a new destination that has to be dealt with. When deploying branch services, one must consider how all of these trends and considerations affect your implementation plan. Data center and branch consolidation are clearly transforming trends that result in the branch being seemingly stripped of multiple services that used to be deployed locally. However, some of those services are now being deployed in integrated network elements, such as Cisco's Integrated Services Routers. The main result is that implementation plans need to include verification steps to identify services such as voice, security, and WAN optimization being deployed at branch routers and their impact in the deployment and upgrade of branch routing services. Other transforming trends include the increasing use of technologies that facilitate high availability, scalability, and resiliency. Solutions such as MPLS VPNs and Internet VPNs bring with them many benefits, but also challenges and complexity in branch routing. You may now have to peer with service providers as part of your IGP, Interior Gateway Protocol, configuration, or perhaps not be able to run an IGP across your VPN at all without configuring additional features. In the end, operational consistency is a critical business requirement. The service and business-ready branch will require a structured approach to configuration and change management in order to provide management scalability and reduced costs. When discussing an enterprise network, it is important to consider that most networks are built from a discrete set of interconnected architectural elements, and each has its own requirements. A branch office, for example, may not have the same scalability requirements as a data center, but has a greater need for reduced form factor devices with high-value integrated services. For the branch office in particular, it is essential to follow an established framework to ensure the best possible user experience in all locations. Because each location type has its specific needs and challenges, using a place in the network framework is crucial to providing the best solutions for each location. It is still important to provide a common foundation across the entire network so that these disparate locations can still interoperate with each other and work as a system. Notice here how the different locations are profiled based on WAN connectivity, size, and functional and service requirements. Let's take a closer look at options for the branch office. Our scenario is that of a hub-and-spoke branch connectivity deployment. Initially, with only one hub and basic services in place, the branches reach the rest of the network via default routes across a private WAN with dedicated connectivity. The hub device routes traffic to the branches via static routes. There is currently no redundancy design to allow for a more resilient branch architecture. Our job is to upgrade one of the branches to allow for resiliency, adaptability, and load balancing in the presence of branch services like NAT, PAT, DHCP, and many others. One of the functions in the scenario will be IPsec VPN tunnels across public networks, and will have to provide end-to-end connectivity in the presence of that design. To illustrate all of these design concepts and trends, we will demonstrate a branch upgrade scenario into IPsec VPN connectivity. We will start with our base scenario, and then build internet connectivity with basic services, such as NAT and DHCP, as an alternative path into the headquarters router. We will then use this link as a backup to our private WAN connectivity using IPsec VPN tunnels. We will have a specific lesson to introduce IPsec VPN as a connectivity option. This will include some of the benefits and drawbacks, including the fact that it will not transfer routing protocol updates for traditional IGPs that are based on broadcast and multicast. That's why our third topic of our demonstration will be to run EIGRP across the IPsec VPN using generic routing encapsulation, or GRE. As part of our migration path into decommissioning the private WAN link, we will test the forwarding of packets across both links using EIGRP's unequal cost load balancing. To accomplish our objectives, we will use a specific implementation plan that will include configurations of the branch and headquarters routers. Each one of these points represents a specific topic of our demonstration lesson. We will first introduce DSL as a broadband connectivity option, then prepare our internet connections with static routing and network address translation. This will be followed by the verification of other services that may be deployed in the branch router before the migration into an IPsec VPN, and the documentation of those services in our branch router. Our fourth step will be to verify and tune the IPsec VPN. Now, this is very important. The objective of the module is to illustrate the impact of IPsec VPNs in routing services, such as routing protocols and NAT. In order to allow us to do that, we are going to have a security services team configure the inner workings and basic configuration of IPsec VPNs in both our branch and headquarters routers. We'll then come back after they're done to again verify the configuration and tune those network services around the VPN. As a fifth step, in order to run EIGRP across the IPsec VPN tunnel, we will use GRE, and we will finish our demonstration with verification and testing. This lesson provided a framework for branch office design considerations and profiling. The design guidelines we discussed are aligned with business and technology trends that change the way we look at branch office connectivity and services. The benefits of consolidation and integration are clear in terms of reducing cost and complexity. Coupled with the reality of a multi-service environment, these trends do add challenges in deploying and implementing the new branch office. We will demonstrate the details of such implementation in our next lesson.